Today, we're tackling one of the biggest, most profound questions humanity has ever asked. And we're going to do it using the tools of a seriously cool field of science, astrobiology. Let's dive right in.
This is the question, right? The one that's been on our minds for centuries. Are we alone? And what's so amazing is that right now, for the very first time in history, we actually have the scientific tools to start looking for a real answer.
So, we're basically going to become cosmic detectives. And like any good detective, the first thing we need to do is understand the framework for this entire investigation.
So, what even is astrobiology? Well, it's not just about searching for aliens. It's way, way bigger than that. It's the science of life itself, everywhere in the universe. How it starts, how it evolves, where it's distributed, and what its future might be, both right here on Earth and, just maybe, far beyond.
Okay, so just think about it for a second. How do you even begin to search the entire universe for life? The scale is just mind-boggling. Well, scientists have to be incredibly methodical. They have to start by clearly defining the search. Now, you might think this is all about pointing telescopes into deep space, but a huge part of astrobiology is actually looking right here, at home. See, to understand the potential for life elsewhere, we first have to understand the fundamental rules of life here. Earth is our one and only example, our template for what might be possible out there in the cosmos.
And this is absolutely not a one-person job. Astrobiology is like the ultimate team sport for scientists. You have astronomers finding the planets, geologists analyzing what they're made of, chemists hunting for the building blocks of life, and biologists trying to figure out what that life could even look like. Every single field holds a critical piece of this giant puzzle. So, if you're going to tackle a question as big as are we alone, you're going to need a pretty specialized toolkit. This includes some really clever assumptions to narrow the search and some brilliant equations to help frame our expectations.
The universe is so vast, you just can't look everywhere at once. So to make the search manageable, astrobiologists start with 3 key assumptions, all based on the only life we know, us. First, they bet that life is carbon-based, because carbon is just so incredibly versatile at building complex molecules. Second, they assume it needs liquid water, the perfect solvent for life's chemistry to happen. And third, they focus on stable, sun-like stars, the kind that can burn steadily for billions of years, giving life a chance to evolve.
But let's be honest, finding microbes would be revolutionary. But what's the question that really gets us excited? What are the odds of finding intelligent, communicating life? Well, a famous equation was actually created to help us think about that very question.
And this is it, the famous Drake equation. Now, it might look a little intimidating, but it's really more of a framework for thinking, a way to organize our ignorance, you could say. We have pretty good data for the first few variables, like the rate of star formation, but as you move down that list, the fraction of life that becomes intelligent, the lifetime of a civilization, we're purely guessing. It's a tool, not for finding a single number, but for understanding all the questions we still need to answer. You know, the search isn't just about passively listening. It's also about reaching out, trying to say hello. This is the Pioneer plaque. It's kind of a cosmic message in a bottle. It's got a little map showing where we are, a picture of what we look like, and it represents this incredible hope that someone or something might someday find it. Okay, so with our toolkit all ready, where do we point our cosmic magnifying glass? Let's go investigate some of the most promising crime scenes, the prime suspects in the search for life. First up, our celestial next-door neighbor, Mars. Now, we see it as a cold, red desert today, but our rovers have shown us that billions of years ago, it was a water world. It had lakes, rivers, a thicker atmosphere. It could have been a perfect incubator for life. That's exactly why finding signs of ancient microbes there is one of NASA's biggest goals. All right, let's move a little further out. This is one of the most exciting candidates in the entire solar system, Jupiter's moon Europa. Don't let that icy shelf fool you. Underneath it, scientists are almost certain there's a vast global ocean of liquid salt water, and it stays liquid because it's constantly being squeezed and stretched by Jupiter's immense gravity, creating tidal heat from within. A hidden ocean world. Just incredible.
And Europa isn't the only game in town. Over at Saturn, the tiny moon Enceladus also has a subsurface ocean. And astoundingly, it's spraying samples of that ocean directly into space through massive geysers at its south pole. It's like it's offering up free samples. We could literally fly a spacecraft right through those plumes to see what's in the water. But what if we look beyond our own cosmic backyard? It's wild to think that just a few decades ago, we didn't know for sure if any other stars had planets. Now, thanks to telescopes like Kepler, we know that planets are the rule, not the exception. We've confirmed thousands of these exoplanets, and the discoveries are just accelerating.
And this leads to a number that is just staggering. Based on all that data, astronomers estimate there could be 40 billion Earth-sized planets orbiting in that just right habitable zone around stars just in our Milky Way galaxy alone. That's not a typo. 40 billion potential cradles for life right here in our cosmic neighborhood.
So, with all these promising leads and these truly mind-blowing numbers, what's the verdict? What has this cosmic investigation actually revealed so far?
After all this searching, with all these incredible possibilities, what have we found? The simple, profound, and maybe slightly chilling truth is nothing. To date, we have found zero confirmed evidence of life beyond Earth. In the entire known universe, we're still a data point of 1.
And this leads us to one of the most haunting mysteries in all of science, the Fermi paradox. The logic is simple. The universe is ancient and vast, and the ingredients for life seem to be everywhere. So, where is everybody? This great cosmic silence is, well, it's deafening.
This paradox leaves us with two big competing ideas. On one hand, you have the principle of mediocrity, which suggests there's nothing special about Earth and life is probably common. But on the other hand, there's the rare Earth hypothesis. This argues that the whole chain of events that led to complex life here, the right planet, the right moon, the right spot in the galaxy, is so incredibly improbable that we might just be alone after all.
And yet, even while we debate all this, our own planet keeps expanding the possibilities. The discovery of extremophiles, life that thrives in total darkness around superhot hydrothermal vents deep in our oceans, proved that life doesn't need sunlight. It just needs water and an energy source. This discovery completely redefines what a habitable world could be, and it makes those dark subsurface oceans of Europa and Enceladus seem all the more compelling.
Ultimately, we have to remember how new this search really is. In cosmic terms, we've just opened our eyes and started to look around. The greatest discoveries are surely yet to come, and the answer to this ultimate question, whether we find an empty cosmos or one teeming with life, will fundamentally change our understanding of our place in the universe. So the only question left is, what do you think we're going to find?